All right. Before you guys ask me, no, we are not going to review for the benchmark. I want to see what you currently know without having to review. That way I know what I need to focus more on once we do get to review for the STAR test. We're going to have all after spring break, or close to all after spring break. We'll be done 1 week after spring break, then the whole month of April to review for the STAR test. So don't worry, you will get enough review. But I want to see what you remember right now. For exponential domain and range, exponential domain and range is going to be very, very similar to linear. So if you feel like you didn't learn domain and range for linear equations or linear functions when I wasn't here, this is going to be extremely similar to it, okay? With the exception of one thing. So example number 1, what is the initial value?
1.
How do you know?
There's nothing in front of the parentheses.
Okay, so if you look at the equation, there's no number in front of the parentheses, meaning that that's number 1. There's another way you can know.
By the y-intercept?
The y-intercept is 1, 0, 1. So the initial value is 0, 1. Growth or decay?
Growth.
How do you know?
Because it's going up.
Correct. You read graphs from left to right. So if I start on the left side and I go to the right, my line is going up and not down. Okay? So that is growth. What's my 0?
4.
Trick question.
Or none.
There isn't one. There's never going to be one. Not for exponential functions. Why? Because of the asymptote. What's the asymptote?
3.
No. What is the asymptote? Like, describe it. What is the asymptote? What he says? It's a boundary, and it keeps the line from what?
Going past the line.
From touching the x-axis. Okay? So you see that red line right here, the dashed line? That's my asymptote. That's an imaginary line that keeps that exponential function from touching the x-axis. So if it's never going to touch the x-axis, that means it's always what? Getting close to what number? Okay, so if I go here to here, which one's getting smaller?
The negative.
Oh, the x-axis. Or the x value.
No, the
Oh,
y.
wait, no, the y.
What's happening to the y value?
It's getting smaller and smaller.
And getting close to what number?
0.
0. But it never reaches 0. Think about it. So get your calculators real quick. So let's say we're taking that zombie, whatchamacallit, the zombie example. The zombies are increasing, they're doubling, right? But the human population is decreasing, right? So it's decreasing by half. Okay, so if we have 100 humans and we divided that by 2. Okay, we're down to 50 humans. Now, if I divided that by 2, what do we get?
25.
But if I divided the human population again, what do I get?
Decimal.
Then what do I get?
Decimal.
Then?
Decimal.
So if I keep pressing enter, my number keeps getting smaller, but what never happens?
Never reaches 0.
It never reaches 0. That E right there, I've told you guys about that on your, whenever you calculated your vertex and all that. Whenever you see an E, that's just 4 zeros in front of the decimal. 5 zeros in front of the decimal. So that just makes it even smaller. And then what happens? 6 zeros in front of the decimal. But it never actually reaches the number 0. Okay? It never, never actually reaches 0. That's because of the asymptote. Now, your asymptote is a horizontal line. What acronym do we use for horizontal lines?
Ahoy.
Correct. We use HOI. Now, what letter in HOI helps us with horizontal lines?
Y.
The Y. What does the Y in HOI stand for?
Y value. Y equals
What number does the y equal there?
0.
Y equals 0. Okay. Now, for exponential only, the asymptote will always, and it's never going to be any other number, will always be y equals 0. Okay? It's never going to be any other number. For exponential functions, the asymptote will always be y equals 0. Got it? All right. Now, to find the domain and range, you have two ends. So you label your 2 points. Label your 2 endpoints. What is this arrow up here?
Positive.
Positive. Okay. Now, think about this one. What would this arrow be?
Negative positive.
Negative infinity. But what's happening to the y value?
It's getting smaller and smaller, but never reaches 0.
0, not infinity. It never reaches 0. Okay. Now, since it gets close to the 0 but never actually touches the 0, it never actually reaches 0, the any infinity you underline, okay? But this one, since it never actually reaches the number 0, you don't include the number 0. That means it will always just be less than, okay? Not underline. We underline the number when you include the number, okay? Remember, 12 and under, or just under 12, okay? So any infinity, you do underline the inequality. But this one, since it's reaching the number 0 but never actually does reach it, we don't underline. Got it? All right. Now, since we're only labeling 2 ends, it makes my domain and range easier because you only have 2 numbers to pick from, not 3. All right. What's my smallest x?
Negative infinity.
Negative infinity. What's the highest?
Positive.
Positive. So when you have infinity on both sides?
All real numbers.
All real numbers. Okay. Look at your y. What's your smallest?
0.
The smallest is 0 and the highest is positive infinity. Now, when you only have one number, one infinity, you keep the side with the number, but what do you do? Flip it around because you want the y, or you want the letter to be in the front. So this one is y is greater than 0. Okay. Questions on number 1? Number 2. What's your initial value? How do you know?
Because there's nothing in front of it and
Nothing in front of the parentheses. What else?
the y intercept.
It crosses the y-axis at 0, 1. Very good. Growth or decay? This one's decaying. If you start on the left side of the graph, it's going down. Okay? What about the 0? None. There won't ever be an x-intercept. Not in Algebra 1. And the asymptote? Y equals 0. The asymptote's always going to be in the same spot. Your boundary line will always be in the same spot. It will always be a horizontal line. It will always be on the 0. So, y equals 0. All right, let's label our ends. What's the top arrow?
Negative positive infinity.
Negative positive. What about the bottom?
0 positive.
Ooh. Which one's getting close to 0? Think about it.
Y.
The y is getting close to 0, not the x. So that's positive infinity, 0. It's always the y value that's getting close to 0, okay? So let's do our domain and our range. What's our smallest x value?
Negative infinity.
Negative infinity. And our highest?
Positive.
Okay, so this one is? Now keep in mind it's not always going to be all real numbers, and we'll have examples where it's not. What about your y values? What's your smallest y value?
0.
Smallest y value is 0. We do not underline that one. What's your highest? Positive infinity. So once again, what are we going to do? Flip it around. Don't forget to also flip the symbol. Ready? Example 3. Notice, what's different about example 3? There's no arrows, so that means we're not going to have any infinities on this one, okay? But I did label the 2 points for you. The initial value is 2. It's crossing the the y-axis at 0, 2. Growth or decay?
Decay.
Still going down, so it's still decay. Is there a 0? No. What's the asymptote? Okay. Now, the point's already labeled for you, so you don't have to worry about that part. What's your smallest x value? -4. Now, look at where the -4 and 10.125 is. What do you see here?
An open circle.
When you have an open circle, you do not underline the inequality. It is just less than, okay? When I first taught you this through a video, when I was gone, I taught you about the open and closed circle. If the circle is closed, that means you do include the number, so that's underlined. Think of the line as what fills in the bubble. That's the juice that fills in the bubble, okay? So, line fills in the bubble. -4, you're going to leave the inequality alone. What's the highest x value? 3. But the 3 is a closed circle, so you underline it. You have numbers on both sides. You keep everything. Okay. For your y's, what is your smallest y value?
0.593.
All right, so I'm just going to write 0.6. What about your highest?
10.12.
Okay. And that one has an open circle, so you leave the inequality alone. You only underline the 0.6. Questions? Flip it over. What is the y-intercept or initial value? 3. You see that in the equation. You see it in the graph. Growth or decay? Growth. What's the 0? None. What is the asymptote? All right, now for the domain, one of the points is labeled. This one, you can actually estimate what it is. What is it? 415. Good. 15 is in between 14 and 16, so yeah. What's your smallest x value? And your highest? Which one do you underline?
-7.
Underline the -7. Leave the 4 alone. All right, which one's your smallest y value? 0.17, and then your highest?
15.
Which one do you underline? 0.17. Good. Number 5. What's your initial value? 3. Growth or decay? What is your 0? And your asymptote? All right. What is the point, the top point?
-1, 4.
-1, 4. Now look at the bottom. The bottom has a what? Arrow. So keep that in mind. What is that arrow? 0. The y value, since this is the side that's getting close to the asymptote, that's where the y value is 0. Okay. That asymptote's the only difference with linear and exponential. All right, looking at your x values, what's the smallest one?
-1.
And your highest? Which one do you underline? Both of them. Good. But we do end up having to flip this one. All right. What's your smallest y value?
0.
And the highest?
4.
4. Which one do you underline?
Both of them.
4.
Just the 4.
Oh yeah, hold on. You don't remember.
You don't underline the 0. The 0 is, it gets close to 0, but it doesn't reach 0. Okay? Real world application. Okay. Remember, you guys know I like to compare this unit to COVID. So.
If Kennedy was here, he'd understand.
Do what?
If Kennedy was here, he'd understand. Because you know how would this apply to real life? That's what all he said.
No, but then he'd have some kind of smart comment to make. All right, the graph below shows the number of daily confirmed cases in the United States since March 1st, 2020. If on March 1st there were 16 confirmed cases and on March 26th there were 73,000 confirmed cases, what would the domain and range of the function be? So, what is the first point? Think about it. It says, if on March 1st, there were 16 confirmed cases.
1.
Let's look at my x and my y-axis. What would you label your x-axis? What do you see on the x-axis, along the x-axis?
Days.
Okay, so these are my days. What do you see along the y-axis? Number of what?
Cases.
Number of cases, not just number of people. The number of confirmed cases, right? So, the very first data that we got, remember, can you have COVID if nobody ever gets infected?
No.
No, you have to start with what?
1.
At least 1. But on March 1st, how many confirmed cases?
16.
So, first day, 16 confirmed cases. And then what would the top number be? What day is that last?
26.
March 26th.
70,000. 73,000. So I'm just going to write 73K. Take the lazy way out. All right. Domain. What's my smallest x?
1.
And my highest?
26.
Yep. Do we underline them?
No.
Yes. Yes. My domain represents the month of March from days 1 to day 26. Okay? 1 to 26. What about the range? What's my smallest y value? 16. Underline. And then the highest? 73,000. Yeah, 73K. So what does my range represent? The number of cases. We went from 16 cases to 73,000 cases in that month of March. Questions?